Hi and welcome to Prototype. We'll be solving the problem for LeetCode 704, binary search. This is another problem in the LeetCode 75 study plan. Let's get to it. So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. And you must write an algorithm with big O of log n runtime complexity. All right, let's go through the example. So we're given a nums array with 6 elements, -1, 0, 3, 5, 9, and 12. And it wants us to find the target 9. And once we find the target, if we do find it, then we return its index. The index is 4. It is the 5th element in the array. Okay, so binary search is a standard algorithm. It works by leveraging a sorted array. It could be sorted in ascending order, as it is in this case, or descending order. It doesn't really matter. And it leverages the fact that the array is sorted so to be able to eliminate half the choices in each iteration, thereby getting a logarithmic runtime complexity. And in this case, it's actually log base 2 of n, where the n is the number of elements in the array. So as an example, in example 1, we can pick a midpoint. It can be 3 or 5. Doesn't really matter. Let's go with 3, though. So we calculate the midpoint, and then we compare the midpoint value, 3, with the target. Is 9 equal to 3? It is not. Is 9 less than or greater than 3? It is greater than 3. So once we know that the target is larger than the midpoint value, we can eliminate half the array, because if 9 is larger than 3, 9 is larger than everything to the left of 3 because it's a sorted array. Therefore, in the next iteration, we search the subarray 5, 9, and 12. We calculate the midpoint out of 5, 9, and 12. It's 9. We found it, so we return the index. And while doing this, we'll be keeping track of the index, essentially. Okay, let's get to it in the code. So we need a left pointer and the right pointer. Let left, and we'll just initialize it to the first element in the array. The right pointer will be initialized to the last element in the array, so array.length -1. And then while left is less than or equal to right, we will be running our check. So what are we checking for is, need to calculate the midpoint, so const mid, and we can do this by doing math.floor left plus right divide by 2. And the reason we have to do this is because by default, there's no integer division. JavaScript uses doubles for their numbers. Okay, so now that we have the mid index, then is the mid value equal to the search value. And technically, the description says target, but we're given s value, so we'll use that. If it is equal, then return the middle index. Else, if the middle value is less than the s value, then what are we doing? Okay, so again, if the mid value 3 is less than 9, again, we can eliminate everything to the left. Okay, so we move our left pointer up to the midpoint, and we do it +1. Else, it is the opposite case. So the search value is smaller than the mid value. So in this example, let's say instead of 9, we're searching for -9. -9 is less than 3. Everything to the right of 3 is larger than 3, so we don't need to search that. We can search the left side. So the right pointer becomes mid -1. At the end, we either find it and we return the mid, or we return the sentinel value that it wants us to return. So return -1. We can run it. Oh, unknown network error. One more time. There we go. Okay, submit. And apparently this only beats 60%. But let's just try submitting again. But I will also switch it to seal just to prove the point that it doesn't really matter. We could math.floor. We can also math.seal. And good old LeetCode. So this time we're beating 86.9%, even though it should be the exact same submission. Couple other things. So instead of doing math.flow or math.seal, we could also leverage bitwise operators. So here, this is casting it to a 32-bit integer, and then doing nothing, doing no change. We're just casting it, basically shorthand for casting. Submit. Okay, so this time only 37%. And one more thing that we could do, we could say left plus right, and then unsigned right shift by 1 digit. And that will give you the left plus right divided by 2 and then truncated. And that was apparently bottom 10%. Let's try it one more time anyway, because this should be faster. Okay, 83. Good old LeetCode. Okay, so time complexity. It is log base 2 of n. What does that mean? If we had an array of size 20, the while loop will run at most 5 times. And if we were to 10x the array size, so with an array size 200, the while loop would only run at most 8 times. This is because every iteration we're dividing by 2, right? So if we start at 200, we check the midpoint, and then it's 100, and then 50, 25, 12, 6, 3, and then it becomes 1. And then it checks the last value in the subarray. So binary search is a very fast search algorithm. Again, it does depend on a sorted array, so can't be used all the time because you'd have to sort it first, and sorting does also take its own, time complexity to execute, which generally n log n. So if available, use binary search. Otherwise, you might not. So this is the solution to LeetCode 704, binary search. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan in short order. Thank you, and see you next time.